So welcome to this week's W3C CCG meeting. Today we are very excited to have Justin Reacher from Bespoke Engineering to actually present and lead a discussion on machine identity in federated systems. So Justin previously has worked on OAuth quite a bit, including OAuth dynamic client registration and token introspection, but most recently he has worked on HTTP signatures, GNAP, which he will actually talk about in a few weeks later. But today, we invited him to actually talk about his latest work in machine identity in federated systems, because previously, a few weeks back, we have a couple of threads, I would say 2-3 threads around this topic. But before we get to today's main agenda, just want to do a quick reminder on the code of ethics and professional conduct. Mainly just make sure that we are respectful to each other and acknowledge each other's perspectives. A quick IP note, anyone can participate in these calls. However, all substantive contributions to any CCG work items must be member of the CCG with full IPR agreements signed. So if these acronyms sounds a little bit daunting and you have questions, feel free to just ping any of the co-chairs, including myself. All right, a quick call note. These meetings are being recorded and automatically transcribed. We will publish these transcriptions basically in the next day, but in the next few days at the latest. We use GG Chat to queue speakers during the call. So type in Q+ to add yourself to the queue if you have any questions, or Q- to remove yourself to the queue. Right, introductions and reintroductions. If you're new to the community or you haven't been active and you want to re-engage with the community, please feel free to just unmute and introduce yourself. I see mostly familiar faces, so. Right, well, at the end of the meeting, if we got time, feel free to just unmute and introduce yourself at that time as well. All right, announcements or reminders. Any announcements and reminders? Kalia, please.
Hi, we've got IW coming up October 10 through 12, and I also wanted to flag another event that I've been working on with the Open Wallet Foundation. We're on the cusp of finally, a go to have an Open Wallet Foundation meeting between 9 and, is it 9? Yeah, 9 and like noon on Monday. And I'm actually kind of curious if people can sort of signal, I don't know, +1 in chat or something, like if they are into, like, we're trying to gauge, like, is there actually community interest and capability of coming to an event Monday morning? So that's the Open Wallet Foundation, that Linux Foundation nest inside Linux Foundation that was founded about a year ago. So there's no link for that yet, but I'm just sort of saying it's almost like a save the date I'm sharing. So thanks.
By the way, Kalia, are there major developments from Open Wallet Foundation that we will be interested to learn about? Because if so, then maybe we should invite them to kind of talk about it.
Definitely, you should invite them to come and speak. Google officially joined the foundation over the summer. They sort of released it quiet, when no one would see it in the late August. But there is like official press release for that, and there's been code contributions by I don't know how to say it. I think it's NPID, the farm worker wallet project. There's I believe several SDJ implementations, and from what I hear, there's more code coming in the pipeline. So the current vision is to present the existing code, and then with everybody who is present, have a conversation / well facilitated by me, brainstorm about what a wallet ecosystem looks like to help inform how to proceed as an organization and an open community.
Great. Cool. I'll reach out and then connect with them. Thanks.
Great.
Any other announcements or reminders? All right, just a quick preview of our agenda. So today we're going to talk about machine identity in federated systems. Next week we'll have FIDO2 and WebAuth then. So we have David Waite to talk about that. So that's more on the authentication front. And then the week after that, Manu is going to talk about selective disclosure for data integrity. And then lastly, we'll have Mike Jones talking about demonstrating proof of possession at the application layer. So that's what's coming in the next 4 weeks. All right. Any updates on the work items or any questions on the work items? All right, let's get to the main agenda. So earlier I just gave a quick introduction to Justin Reacher, and he has worked quite a bit on the OAuth side of things, and then most recently we connected with him in regards to Connect, which he will present in the next few weeks. But also he mentioned about machine identity in federated systems work that he has been working on. So, which coincides with the conversation thread from a few weeks ago in regards to this topic of not just human identity, personal identities, but machine identity. So without further ado, Justin, the floor is yours.
Wonderful. Thank you for inviting me. It's good to be back at the CCG. I try to make these calls when I can. My schedule doesn't often allow it. I'm going to be sharing out a presentation, so just give me a moment while that loads up. All right, I just want to confirm that that is still sharing, and you should be seeing the full screen of the slide. Is that what you guys are doing?
Looks good.
All right, fantastic. So hello, everybody. My name is Justin Richer. I know many of you from various standards work over the last couple of decades here. And today I'm going to be talking about some new work that I've been getting involved with in the SPIFFE community and the IETF community, and also, how it touches around OAuth. And that is specifically around this concept of workload identity and what that actually means. So let's start with a really basic question. What is a workload? Well, one definition that I think fits really well is that it is a single piece of software deployed with a specific configuration for a single purpose. So when you've got a piece of software that does exactly one thing, and it only does that thing, and you have it configured to only do that thing, that's the type of thing that we're talking about for a workload. So say that it is a signing service. It takes in the document, it applies the signature and returns the result, right? Or on the other end, a validation service that takes in a signed document, manages pulling the keys, validating the signature, and returns the result back to the system. One of the important things about workload, especially today, though, is that you can have many, many copies of these things. Our notion of what a computer is and what a server is today is pretty different from what it was 20 years ago or even 10 years ago. And one of the key differentiations for this notion of what a workload is, as opposed to what we might traditionally consider just a service or a server, is that the whole idea with a workload is that they are repeatable, that you can spin up a bunch of these, and because they do a single thing, you can make lots of copies when you need them, get rid of the copies when you don't need them. So fundamentally, that's what we're talking about for workloads. So what does this have to do with identity? We've got software, it's running, it's doing things, that should be good enough. Well, let's say we've actually got 3 different cloud services. All of these comprise different workloads in the system. When we spin these up, we want to know which one is which, and we want to know things like how do we get things like identities and secrets into these systems. I want to be able to tell the difference between the orange system, the yellow system, and the green system, right? I need to be able to know when the green system is running that it is, in fact, the green system. I expect it to have a particular configuration, be taking certain actions, and that can help me make decisions about what I expect it to be allowed to do. So SPIFFE is a project of the Cloud Native Computing Foundation. It's an open source project with a reference implementation and set of community standards in CNCF. And basically, the way that it works is that you run an agent in your environment where all of your workloads are running. And when your workload wakes up the first time, it calls the SPIFFE agent and says, like, hey, here I am. Who am I? These workloads are not pre-configured to really know their own identity. They don't get pre-configured with a secret that lets them call this agent, and then that gets them the right identity, because then you have to answer the question, well, how do you get that secret into the system in the first place? SPIFFE is really clever in how it stands up, because when these agents make this query, it can do all of this. It can create identifiers. It can generate certificates and trust roots and keys and provision out the right ones to each of these systems by basically looking at the environment of the workload itself. So it takes a look at the workload, and it can do all sorts of things like, which Kubernetes node is this running on? Which, what's the hash of the software that's running on this image? Whether it's Docker image layers or what have you. What is the runtime footprint look like of this? There's all these things that we can look at about this software to know that only certain things are supposed to be running in this place at a given time. And so when we see all of those, that's how we know which piece of software it is. And like I mentioned, the SPIFFE agent allows us to hand out the right keys to the right agents. So we can now hand things like certificates and tokens and whatnot to, for example, the orange service that only the orange service gets, and only things that look like the orange service gets. So if I have thousands of copies of that orange service, then they're all going to get the right keys so that they can do orange service kinds of things. Now, what do I mean by that? Well, let's say that we're actually bundling our services together. So the orange service needs to call the yellow service, which needs to call the green service. This is really one of the core things that SPIFFE solves, because each of these has their own identity and it's paired with cryptographic material. The yellow service, when it gets this call, it knows that the orange service is making that call. And likewise, the green service knows that the yellow service is making that call. And we can do this using mutual TLS. We can do this with, there's current work to do a sender constraint profile, token profile, using OAuth style tokens inside of the workloads. Mutual TLS is the most common today by far. But each of these nodes knows a little bit about the caller. But this is also kind of where SPIFFE starts to fall over sideways a little bit. So let's say I'm down here at the leave service, down at the green node. I want to know not only is it the yellow service that's calling me, but I want to know that the orange service called the yellow service in order to call me. I want to know that this call that's part of my workload propagated through the appropriate channels in the appropriate chain before it gets to me. TLS is hop by hop. It doesn't tell us that kind of connection information. OAuth tokens are meant to go in one side and kind of get passed through. So that doesn't tell us this information. This is kind of a gap. And this is one of the spaces that some of the new work that I'm doing is starting to look at. Because we want to be able to answer more complex questions like this, given this base model of we have a workload that gets an identity and a set of cryptographic material with it. What can I now do with that? What kinds of questions can I answer? And this gets more interesting when we actually start to label our stuff. So let's say that the orange box is actually an API gateway, and it calls the foo service, which in turn depends on the bar service. Now, the reason that we would set this up is that there's probably an external client out there somewhere that's calling our API. And this presents an interesting security architecture problem, because it's the client has the access rights, but that leaf node is the one that has the data that the client wants. So how do we even start to talk about propagating this kind of stuff? Well, in the OAuth world and similar protocols like GNAP and others, we solve this problem by ignoring it. We wrap all of that those workloads inside this concept called the resource server. We abstract it. And so for OAuth's purposes, the resource server is a solid block. The client doesn't care how it's implemented. And I would argue in most cases, nor should the client actually care. It knows to call the gateway, and it knows that data comes out of the gateway at some point. And from the client's perspective, that works great. And this abstraction is actually super powerful because it allows us to answer higher order questions like, we have a resource owner and an authorization server that allows delegation to the client software. And we can even do some fancy tricks like having sender constrained access tokens. So the client calling the resource server is the only piece of software that's allowed to use that client because it's been bound to a key that only the client has. But the problem comes from the fact that inside, we don't really know what's going on, which means that all of our assumptions from inside this bubble and outside this bubble start to fall over. So let's take a look back at that sender constrained access token. The client is the one presenting the token to the resource server, but we need to get it all the way over to that leaf node in order for it to make sense, because there's going to be information in that token or associated with that token that the leaf node needs to care about. So what do? The client is the only entity that can present that constrained token by design. We don't want other people to be able to present that token, at least not outside of our workload chain. But we definitely want the gateway to be able to pass that token along to the foo server and the foo server to pass it to the bar server. But they're not bound to that token in the same way. They don't even necessarily have access to the authorization server. So how do we start to solve that problem? And what's interesting is that in practice, this is something that people run into when they're building out real systems. In practice, people solve this in a bunch of clever ways. So in some systems, they will strip off the sender constraints once you're inside this environment and just pretend that incoming token really was just a bearer token all along. Sometimes it'll get exchanged for a different internal token that only the internal services can use. Sometimes the external token gets wrapped inside of a new internal token. And there are other patterns out there as well. But none of these are really standard practices. None of this is really defined by a document that says, here's how you can solve this, and here are the trade-offs that you need to consider when solving it in this particular way. And it's not really clear with all of these patterns how we get this external information, like who the resource owner was, all the way down to that leaf node. Let's say that leaf node is a signing service that foo needs in order to fulfill the request. Well, the leaf node needs to know whose keys it should be using, which escrowed keys are stored there that it should be using to sign the document to hand it back up to the client. you know, the foo service and the gateway service aren't going to have access to any of those keys. But the bar service, it needs to know who that original resource owner is. And yeah, we can pack that into the token, but as we saw, we might be wrapping that token. We might be changing that token for something else. We need to have good patterns and good standards to be able to do that. We don't have that in the community today. We've got a lot of sort of interesting point solutions. Moreover, though, that Leaf node probably wants to know a lot more about the world. We not only care about the resource owner, we actually care that the token that I'm seeing, did that come from an appropriate authorization server that I should be trusting? Did that come through the front door from a client that should have been able to present it? And is the chain that that made this request get to me, is that standing up? So in some systems, we'll say, you know what, we will put this whole notion of which AS and which client and all of that. We'll just code all of that into the gateway and then abstract that and send it down the chain. That's great. But then you really, really, really need to know that this gateway did its job and was involved in the process, getting all the way down to this bar service. Even having just one node in the middle makes that harder to describe and harder to solve. But it gets even weirder, because in today's systems, we're really not even talking about just deploying all of these little workload modules in a single cloud environment anymore. People are building out lots of interesting services that run across multiple different cloud environments, multiple different cloud systems. And so you can have something that goes all the way down the chain. And at that point, I need to go call a different API to fulfill this, which means I'm now getting outside of our container environment and jumping inside a different container environment. So when I get all the way down to that Quux node in the lower right-hand corner, how do I answer that this chain is actually valid? Like, how can I even start to talk about the path, which might not even be linear, that this request went through on its way to me? Because that foo service may have called something else and done some sort of side processing before it went to call the bar service. And the Quux service that's on a different cloud might actually really care about that. For example, that foo service could be calling out on the side to an audit and compliance service. And so by the time the request gets all the way down to that Quux node, the Quux node needs some assurance that, yeah, that really did go through, or else it could be, you know, it could be us on the line. But this gets weirder still when we start drilling into this, because remember those external things that we've been kind of ignoring now, the AS and the client? Well, the truth is, a lot of those probably have their own internal call chains as well, their own internal workloads, all depending on how you build and deploy systems. And if I'm building out something that I really want to have an assurance about how things work, we need to at least be able to talk about these things. And there's a lot of times in this where, yeah, I might need to abstract this and say that, yes, the client is valid. But sometimes I need greater insight. So as I hope you can see, the problems that people are seeing today go a lot further than just, did the right user delegate to the right piece of software? Or is this token valid? Or even, did the right instance of software get the right key when it booted up? You start building and chaining these things together, and you can build some amazing systems, but you start to see the cracks in where, in between, where the standards come together. And that's the question that we recently took to the IETF. Now, the SPIFFE community wrote a book and coined this phrase that I love, that SPIFFE is about solving the bottom turtle. So if you guys are unfamiliar with the phrase, it's turtles all the way down. Very roughly, the world is perched, and I'm butchering this, but the world is perched on the back of 4 elephants, which stand upon 4 tortoises. And somebody asked, well, what's underneath the tortoises? And well, that's another tortoise. And then it's turtles all the way down it's an infinite recursion philosophical problem. SPIFFE solves the boot keying issue and the boot identity issue for new software waking up in this environment. So it solves that initial turtle. We can get keys to a piece of software fairly reliably. And so one of the questions that we brought to the IETF this summer was, are there parts of this bottom turtle problem that make sense to address inside of the IETF? But more importantly, in my view, is that if we even assume that we can do that, what other questions does that allow us to ask? Are there other turtles in the stack that we can now care about and we can now talk about? Some of these questions, like if I go back here, like we don't even really have a good common vocabulary for talking about how these chains propagate, how we talk about assurance between these things, how we identify the entities between these in a way that is consistent and actionable. We need to really start that conversation. And so that's what we're starting to do. There's a new mailing list in the IETF called WIMSE, Workload Identity in Multi-Service Environments. And we are just getting started. This was put together just before the IETF in San Francisco, which was last month, I think. It's 2023, time is weird and makes no sense. But at the last IETF meeting, we put that together. The list is there, it is active. And because this is an IETF list, anybody can join it. It is a public list, and I encourage you all to do so if any of this problem space or any of the potential solution space is interesting to you. We're hoping to potentially get a new working group in the IETF to start working on some of these problems, and we're starting out that process now. And with that, I will be happy to take questions and any conversations that people might have.
So Justin, I'm just curious, is this similar to kind of the object capability security model, like, or like, is it analogous to that, or is it a little bit different? Yeah.
Oh, it's different. So this isn't just about how you create a capability and propagate it through the system, because a lot of times you don't actually want to be using pure capabilities. You want to use stuff that is limited, so that the security artifact can actually be only presented in sort of the right environments in the right places. So this isn't trying, but more fundamentally though, to answer the question better, this is not about trying to create a new security model. This is about trying to model the security of these kinds of environments that we have that we didn't really have an analog to previously.
Got it. And then, like, what do you envision the business use cases are? Is this mostly just for kind of DevOps trying to understand their environments, or maybe multi-cloud like environments that you just mentioned, or what are the kind of business use cases?
Yeah, so that's some of the driving use cases that people have started out with. But to me, I think it goes so much farther. One of the things that actually got me interested in this was not actually the workload identity itself, but the kinds of things that we could do with this type of technology at a more macro scale. So let's say, for example, I've got a user that is logging into my system for the first time, but I'm actually taking their identity in from somewhere else. So let's say, for example, they did a federated login, or they presented a VC or something like that. And when they do that, I'm going to create an account in my system and you know what? They've got a FIDO token. I can take that as a local authenticator and bind that to that account, and I'm good to go. But I can also then take and make that same user account available elsewhere. I can be a sort of a federation proxy and make that available to someone else, or I can issue that user a VC that's rooted in my environment that they can go take elsewhere. And when the user shows up down there, suddenly you've got a lot of the same types of questions that you can ask about where did this come from? What kind of path did they take? How can I prove that? And how much does that mean to me? Because it might also be nonlinear in this case, just like we were talking about that one service that might be calling out multiple things. I could take in a user that gave me a federated login from 2 different IDPs and bound them to the same account, and they presented a VC from somebody else, and all of that is tied into their account. Maybe they did that because they needed to do a higher level of identity proofing, and that's how they presented their proofing information. Well, now that I have all of that, that's meaningful to me. And it might be meaningful to the people that, to the systems that that user might be connecting with downstream from me. And it's a lot of the same types of constructs and concepts that, again, we don't really have a good way to talk about this kind of provenance graph, if you will, of entities and artifacts and identities moving through these systems. So to me, that's one of the more interesting business drivers, is all of this at kind of a macro level. At a more sort of immediate level, the bit that I mentioned about being able to handle sender constrained tokens even inside of a single cloud environment, that's a huge problem that people are hitting today. You know, there are systems that the gateway strips off the sender constraints and passes along the bearer token. There are systems that wrap the token inside its own internal JOT that then needs to get figured out downstream. You know, all of these different patterns that people are implementing, often without really fully understanding what the trade-offs are and what the sort of the hidden considerations might be. And that's, to me, where the standards community can really help, because we can get together experts from all of these different fields that have similar problems and similar solutions and figure out what the commonalities are. What are the real patterns that people should be applying here? If I make this decision to, for example, switch to bearer tokens internally, what does that mean? What should I be thinking about? What extra things should I be protecting against in the case that I'm making that decision?
Got it. Thank you.
To help with that, I'll actually I'll drop it into the chat. There is a use cases document that a few of us have put together, and is an IETF internet draft. So this is not an IETF draft. This is not a standard. This is for those unfamiliar with the IETF process, an internet draft like this carries about as much weight as somebody's blog post, just to be clear about the nature of this. That said, we put a bunch of work into this to document sort of the core, a core set of considerations that we would like to be able to look at inside the WIMSE work as it goes forward. There are others as well.
Got it. And since we got a little bit more time, I'm just curious, what are the trade-offs of the different solutions that you mentioned? Like, for example, stripping out the binding elements of sender tokens, and or wrap it into another token, that kind of things. What are the trade-offs? And then personally, what do you think is, because you mentioned in this stack you talk about the problem statement. So what do you personally think is the kind of the direction for the solution?
I'll answer the second question first, in that the direction of the solution honestly depends mostly on what are the details of the specific problem that you're trying to address. There are a lot of related problems here, and how you go about working with those is going to be different depending on what it is you're actually trying to get done. For example, some systems need extremely high performance when you're going out and working in all of these different nodes. So the overhead of calling out to do a local token exchange, even to a local authorization server, can be deemed to be too much. It's you're taking a performance hit every time you do something like that. So you want a solution there that you can apply locally. One of the trade-offs of, for example, stripping out the sender constraint portion is that you now no longer have any binding between who's presenting the access token to you and the token you're being presented. You have to fully trust that the service that's presenting stuff to you is supposed to be presenting that particular token. And there's nothing in the system that can actually tell you that directly associated with the token, at the very least. Unlike if you had a sender constrained token, you would have a good amount of assurance that not only is it the is the token valid, I can validate that. Not only is the sender valid, but they are actually tied to each other in a way that's meaningful to me. So this brings up an interesting point, though. In the OAuth world, a number of years ago, there was an RFC published for how to do mutual TLS binding for OAuth access tokens. And this is some great work. It gets used all over the place. One of the interesting things about that work, though, is that the OAuth community largely looked at it as we are adding TLS protections to OAuth tokens. So we have these OAuth bearer tokens, and we are adding this TLS presentation binding to the OAuth token so that we can actually be sure that the piece of software that was supposed to see this token is the software that is sending this token. So that seems pretty reasonable, especially when you're coming at it from the OAuth perspective. Funny thing about that, though, is that the reality was actually the opposite. If you look at the way deployments of OAuth MTLS are, and especially when things first started, what happened was that it was people that were already doing mutual TLS, like, for example, many systems in the SPIFFE community, they're already doing mutual TLS. And the access token got added to that. So in other words, I now no longer just have to say, oh, I know the identity of the service that's calling me, and they're allowed to just do whatever on my API because I know who they are and I trust them to just always be correct. I can now add constraints based on the token that they hand me, because they can give me a token that is like, yes, this token says you're allowed to transfer money out of a specific account. That's great. Oh, hey, and this token was given to you. So I already know that you're allowed to make this money transfer call. You're allowed to do that kind of thing on my API, but this token tells me exactly what I'm supposed to allow you to do. It can tell me an amount, it can tell me a destination, it can tell me a source, it can tell me all of that other stuff that I now no longer need to, like these security properties that I now no longer need to encode in my API. So, it's similar to in OpenID Connect, when you call the user info endpoint, you don't give it a user identifier. You just say, give me the user info for whoever's there, whatever the current user is. And so because of that, makes it really simple to program and really simple to understand. You're not putting things into the API that you don't have to expose. And it's a similar pattern that we see with the sender constraining. So when we start to strip that off inside these environments, because we're now no longer talking directly to the client application to whom the token was issued, we need to start making that kind of trade-off. And there are other systems out there that allow you to, for example, have a redelegated token, either through a token exchange or through some, magical downscoping like biscuits allow you to do. And that can be helpful, but you also still need to be able to tie that to the identities of the presenters in order for it to be truly meaningful.
Got it. Thank you. And then Alan, you're in the queue.
Yeah, so you've been talking about bearer tokens, but are signed certificates as the capabilities address some of these issues? Nope. Okay.
No, it's because I actually haven't just been talking about bearer tokens. The issuing a certificate that allows you to do a specific thing, and only that specific thing. If we're talking about sort of rapid issuance of a certificate for a given call and a given purpose, and tying that to the MTLS layer, you could do that. But then that's effectively a moving a lot of your sender constrained security properties into the processing of the transport layer. And it still only lets you go hop by hop. Because when I'm down on that leaf node and I have a whole chain of things, I want to make sure that that chain was actually followed before it gets to me. And, certificates alone don't give you that.
I didn't think they addressed everything. Some of the issues, like for example, you may want to be able to the authorized party may want to be able to delegate. Mutual TLS won't allow that. So, but a signed certificate would.
So here's the thing. One of the conversations that's been happening on the WIMSE list just in the last week is a lot of people saying things like Alan just did, like, oh, I know about something that solves part of this problem. And that's fantastic. There are lots of things that solve parts of these problems. I could go out and build a system out of mostly existing components that will work, and it'd be all right. I'm fairly confident and competent in how to build out a securely architected system at this point in my career. But here's the thing: there's not really a sort of well understood set of patterns and recipes and stuff that we can use that start addressing these larger problems that come when you start putting things together. So yeah, absolutely. There are bits and pieces of the solution out there to lots of parts of this problem. And to me, that speaks even more strongly to the need to get the right communities together to discuss the larger problems and the larger solutions that come when you have these pieces.
And I agree with you. I was just thinking of some of the pieces that you hadn't mentioned.
Mm-hmm. Yeah, there's a lot of pieces that I didn't mention specifically. So there's work the folks at Signal, not the instant messaging thing, the other one, the shared signaling Signal, SGNL for the transcriber, that are looking at transaction level token exchange. So when I can pay the cost of getting a new token at the gateway level, where do I put the incoming token? And that particular solution is looking at using Jose. So it's a lot of sort of embedding and token composition, and the data structure kind of like grows linearly as it goes through the system with everybody that needs to be able to touch it. And that's one possible solution to part of the problem. And there's also stuff like, if you're still in the Jose space, various JOTs and selected disclosure JOTs and things like that allow you to sort of peel off different parts of the token as it goes through the system and expose it only to the parties that need it. So there's some interesting work that's happening there. SPIFFE itself is a really well-used and well-understood solution to its specific problem of, I've got a piece of software, it needs keys. How do I get that? Like, if you want to understand it, honestly, I should have started with this. The use case that really made it make sense to me is that, how many systems have you started up and you need to go connect to a database, and you've got to go jam a database password into your code or configuration or environment somewhere? How do you make sure that only the systems that are supposed to have access to that database get that password? That's exactly the kind of problem that SPIFFE solves. Because when that software wakes up, it doesn't know what it is. It just knows that it needs to make this connection and have a value filled in somewhere. The SPIFFE agent figures out, you are this software with this hash, you're signed by, this CI chain or whatever other bits that you want. And so use this value when you go make that call. And so we can now provision that type of stuff out in a way that that actually makes sense to the rest of the system.
Any last questions? All right.
All right.
I don't see any more questions in the queue. So thank you. Thank you, Justin, for actually lead this discussion on machine identity. I love it. Really enjoy it. Learned a lot. And thanks for taking the time.
Thank you so much. I want to encourage everybody here to please join the WIMSE mailing list. That is WIMSE at IETF. And read through the use cases document, and please join the conversation. We're at the stage right now where we're trying to show the IETF that there is enough interest in this community for this set of problems and this set of potential solutions that we can, that it actually warrants setting up a new group in the IETF. So please join the conversation.
Sounds great. Cool. Any last topics that people want to bring up? All right. This concludes this week's W3C CCG meeting. So thanks a lot.